All right, in 5.2, proving trig identities, the key word on that is going to be proving. Okay, so they're going to tell us now what the answer is, and we've got to show that it's true. Some steps to proving our trig identities. You're going to start with one side. How do we pick the side? Usually it will be the more complicated side as you look at two sides of the equation. Sometimes that's not going to be obvious. That's what practice is going to help us figure out. And sometimes we're going to pick the wrong side. So we'll have to trial and error. Sometimes you'll get into a problem and see it's not going anywhere, and you'll start over with the other side. After you pick the side, you're going to use algebra and your identities to change that side. You can make the one side look like the other. The other side will not change at all. You are only changing one side ever. The other side remains exactly as it starts. And you can only do one move at a time. So although some of us might be able to do a couple algebraic steps in our head, and the key to this is that we are proving it, and so we have to show our proof as we go. All right, so first example. Given something like cosine secant over tangent, we are going to show that it equals cotangent x. So as we look at this one is a pretty obvious problem as to which side is going to be more complex. And again, that's the side that we would pick to manipulate. So we are going to change this side to match the less complex side. And you do not change the other side. So we will only be working in this problem with the left-hand side. Once I get the left-hand side to say cotangent of x, we are done. So let's move to our left-hand side. Cosine of x, secant x over tangent x. One thing that I might want to do is work on the top part on the numerator. So we've got cosine of x, and I'm going to change that secant of x into its identity, 1 over cosine of x. So I've got a cosine of x at the top, and a cosine of x at the bottom, and we can cross those off, which leaves us 1 over tangent x. And again, keeping in mind what we are trying to match here. Well, 1 over tangent x is cotangent x. Oops. And now that I have it matching my original, we are done. So again, this part right here, nothing we can skip in there. We have to show our steps, so I can't jump from like the top line to 1 over tangent x, or I can't skip the showing 1 over tangent x. I can't do more than one step at a time. On our way, that is the proving part of it. All right, so next one, prove the following: cosine times quantity tangent x plus sine x cotangent x equals sine x plus cosine squared x. So both sides are a little complex. How can I go from, or how do I pick the more complex side? On the left-hand side, we have 4 different functions, and on the right-hand side, we've only got 2. And it's easier to condense than it is to add functions into the problem. So if it were me, I would pick the left-hand side on this, the one that's in the cotangent, and try to get those written as just sines and cosines. So again, I'm going to focus on the left-hand side of the equation here, manipulate and simplify until it says sine plus cosine squared. And once it does, I'm done and I've proved that these two expressions are equal to each other. All right, so one of the things we could do is start by rewriting everything into sines and cosines. And the reason I'm doing that is because eventually I want it to be an expression that only has sines and cosines in it. So tangent I can replace with sine of x over cosine of x. Sine of x, I would leave. Cotangent of x, I could replace with cosine of x over sine of x. And this expression right here, I see that I'm multiplying, and again, order of operations, I can multiply that first, and I can get the sign in the top and the bottom to simplify. And that would leave me cosine of x. The next thing I could do is take this cosine of x out front and distribute it through to every term inside. This next step, I will say this next step is optional, but as we're showing our work here, so I'm taking the cosine of x over 1 times the first term, which is the sine of x over cosine of x. I'm also distributing, so cosine of x over 1 times cosine of x. That would be times the second term. All right, so in the first one, cosine of x on the top and bottom are going to simplify, leaves us with, sine of x. Cosine of x times cosine of x is cosine squared x. And we now realize again, always keeping in mind what we are trying to match here, and it does, so we are done. We have proved that those two expressions are equivalent. All right, in this next one, very similar on the left and the right hand side. We've got a tangent x plus cotangent x equals secant x plus secant x cosecant x. And so how do I decide which one is more complex? 4 different trig functions all the way across. Neither side is sines or cosines. So how do I make my decision on what's more complex? When we have something like this, I would decide that the left-hand side is more complex. Typically, it is going to be easier to go from something that has pluses in it to something that doesn't. It's harder to go from like the right-hand side that just has the secant, cosecant with no addition to get to something that has addition. It's usually easier to get rid of that, to like combine terms, than to pull things apart. So again, on this one, I would be focused on the left-hand side of our equation. The link typically between secant and cosecant might be going through sines and cosines. So I might rewrite tangent x as its sine and cosine identity, which would be sine over cosine. Cotangent then being cosine x over sine x. And to put together again, I don't want the plus sign in there anymore. And so to be able to add this together to be one thing, like we have over here on the right-hand side, we would get a common denominator. So getting a common denominator on this first fraction, our common denominator is b, representing all denominators, so cosine x, sine x. And so in that first fraction, we're missing the sine x. And so we would end up with a sine squared x. In the second one, we're missing the cosine x. Now, showing the actual, what I'm writing right now, the actual getting the common denominator, that would not be required. As far as proving, getting a common denominator definitely would be required. So then we would be able to put our fractions together over the common denominator. Again, I get that some of you know where this is going. The point of this whole section is to show the proof that these are equivalent, and the proof is in these steps. And so make sure that we are always showing our work here. And then I can see that the numerator is one of our Pythagorean identities. I can replace that with 1. Now this next part, you really could just jump to the answer. This is 1 over cosine times 1 over sine. One over cosine being secant, 1 over sine being cosecant. And again, as soon as it matches our original, we are done. Okay, so again, let's start with our discussion. We've got a cosine squared minus sine squared equals 1 minus 2 sine squared x, and the discussion is always going to be which side is more complex. They have become less and less obvious as we've gone. This one again continues to be less obvious. already in terms of sines and cosines on both sides. So deciding to go towards sines and cosines is not going to make it more obvious. Both sides have a subtraction in them, not super obvious. So how do I pick? It will always be easier, not always. It will frequently be easier to move towards having only one function instead of in throwing in a function that's not there. So what I'm saying is I think it will be easier to simplify the left-hand side to try to remove the cosine squared than it would be to try to take the 1 plus 2 sine squared x and get a cosine to appear in that side of the equation. So again, on this one, I'm going to pick to work with the left-hand side. So what is the difference between the left-hand side and the right-hand side? Well, one of the differences is it does not have a cosine squared in it anymore. So I think about cosine squared, and it's in my list of Pythagorean identities. As I'm working towards not having it in there, I could replace that with its Pythagorean identity, which is 1 minus sine squared x. And then we've got the minus sine squared that was already there. And so then I see that I've got like terms. Sine squared and sine squared are like terms, like an x and an x. And so if I have a negative 1 sine squared minus 1 sine squared, that is a negative 2. Sine squared x. And actually, we are already done because that matches the right-hand side of the equation. So when given a problem like this, everything's in sine cosine. Which side do I pick? Pick the side that has more functions. It's always easier to replace and eliminate than it is to throw in a function that is not currently there. All right, last example here. And on this one, again, picking which side. I like this example because we've been picking the left-hand side every time. And as I scan through this, again, very complex everywhere, but I would pick the right-hand side on this one. It will be easier to combine two terms to get a fraction than it would be to pull apart that one fraction to have something with a subtraction in it. So I would probably work with the right-hand side on this one. What I might do again, because I'm trying to put it together to be one fraction, and which means I would want to get rid of that subtraction there, is get a common denominator. So let's look at things as fractions. Secant, I can rewrite this one over cosine, which means then we want to get a common denominator. So I would have multiplication of cosine over here. Just be cautious, we're not going too many steps at one time. So I can add the numerator to be 1 minus cosine. One minus cosine squared is our Pythagorean identity, so I can replace that with our sine squared. And at this point, we have some manipulation to do. I need to be, because again, this is what I'm trying to match. Tangent y over cosecant y. So one of the things I could do is factor sine squared is sine y times sine y. Well, sine of y over cosine y, that's where our tangent is coming from. And then the last sine of y we have right here, because it's in the numerator, if I were to slide it to the denominator, I can write it as its reciprocal, which is what we're seeing up there. So I can slide that sine down to the bottom and make it a cosecant. And now we match the original, and we have proved that those two expressions are equivalent. So sometimes it takes a little bit of creativity using our algebra, using identities. Again, that's not how I would have simplified this one in 5.1, as I was trying to make things as simplified as possible, but that's not our goal right now. Our goal is to match the other side, whatever that other side is. We don't simplify fully, we just get it to match. All right, your assignment is going to be worksheet 5.2a. For our temporary distance learning plan here, we're going to shorten that. On that worksheet, your assignment is to write out very legibly answers to problems 1, 3, 4, 5, and 6. Those problems, once you have those written out legibly, you will be taking a picture of your work and attaching it to Google Classroom's assignment for worksheet A. I will tell you that you have access to all problems on worksheet A, and after your due date, you will get the answer key to all of those. So if you're feeling like you would like a little bit of additional practice at any point, you have all of the extra problems on there. And we may pull some of those also to talk about in our Zoom session.